Okay, so the today class is going to be to run by Pieter Kempeneers, and we have been working together with Pieter like 10 years ago, and we had many years ago. So, but now our brain is very full of coding, so we lost our air, but we're still friend even without air. So, I'm happy to invite him every time that I can and that he can accept for working constraint and so on, for running a lecture in the tools that has been developed from already probably 20 years. As a PK tools, you have seen in the powers of these tools in the Bash environment. And today is going to show you what is working the last probably 3-4 years for the PyGeo application. That is a wrapper around PK tools for working directly in Python. So in order to do this, you need to download the first the scripting procedure that is going to use it, and you have to run the typical go to the CD home user in the virtual machine, then run git pull and do the synchronization. So I'm also doing with you guys on the virtual machine. So you can see here the virtual machine. So you do the, oops. You be sure that you are inside the CD home user, sorry, SC data, home user SC data, and then you do the git pull, okay? And this one is going to be synchronized with the GitHub, and is going to download, you can see that it's going to download a bunch of scripting procedure, in particular, the one that we are going to use it today, PK tools, should we? Yes, PyGeo PK tools and PyGeo introduction. Okay, and then as usual, you do an rsync, so you should have rsync directly in your command line, so you can do the typical Control R for search for command and then run rsync. And this one is going to bring your scripting procedure, your script inside the usual folder SE my data. Okay. So and then you classical change my data, you change it to my data, and under exercise you will have the scripting procedure that is going to use it today, the PyGeo PK tools, no, PK tools, no, how it is? PyGeo, yeah, PyGeo PK tools and PyGeo introduction. Okay, so some of you have had a problem with the installation. So Pieter probably is going to be run once again the installation procedure, in particular running 2 commands that they should solve the issues. So I give the floor to Pieter.
Thank you, Giuseppe. I think that in the chat there are still the 2 commands, correct?
Yes, I will paste it again just in case they don't have it. 1 second. So this one. So run it in any case before the installation. Of course, if your installation was running fine, then don't do anything. But if you had a problem with the X-Array 16 version that was not accepted, then run these 2 lines. Especially Olivia, that we were talking before.
Maybe we can have an overview of the number of people that had a successful installation and the ones that have not, that
Yeah.
we can know how many people we're dealing with.
Yeah. Let me do open question. You can see the question. Answer is missing. I don't know how to do it. Means was trying to use this question and answer to see. Okay. But I don't see the Q&A how to do it. Open question, answer question, dismiss. Probably we have to do in advance.
maybe. Are all the participants able to write in the chat?
Yeah, yes, they should be able to write, yeah.
And people can raise their hands also, can they?
Yes, okay, let's do it. Who has been successfully installed? Raise the hand. Easier this way. Successfully installed.
Successful means you can open Python and then import PyGeo without an error message. Okay,
yeah.
can we? So I see. So far, only 3 hands, correct? 4.
Okay, so I think it's better if you sharing your terminal.
I am not though here on the virtual machine. I am in my machine here.
Okay, just in this way you can type in the terminal and don't enter.
Yeah.
You can type these 3 commands and maybe just don't press enter in your machine.
Let me check
In this
if
way
I'm
you
also
can
able to share this like share screen window.
share it.
Not yet. Hold on.
Okay, yes, we can see. Yeah. So you are in mute. So you can run these few lines in order to remove the X array.
Now I'm unmuted, right?
Yeah, you are mute, but you stop the sharing.
Because when I was sharing, I suddenly got muted. I don't know why. Let
Okay,
me try
try again.
again.
Ah, you're right. Ask to unmute. Yeah, now you should be fine. I know. Okay, but you are not sharing.
Yeah, but each time I share, I get I got muted. I don't know why. Also unmute. Okay. Try again. If I share another screen,
Yeah, you are again mute. Oops.
and now?
Yes, now it's fine. Perfect.
And you see my screen also?
Yes. And I see
Okay.
the introduction to PyGeo.
Yeah, but okay, so I need the others. So I need to unmute when I share the screen. Okay, let's try again.
Yeah, you're still on mute. I can see the screen.
Okay, so each time I share my screen, you need to ask me to unmute, and then I can unmute.
Anyway, strange. Anyway, fine.
Yeah. So you enter these two commands from these two here. This one, and then also the other one.
May I ask, we do this in the shared folder or in the home
No,
folder?
yeah, this one is the terminal. Any way can be fine. Any place.
Any place is fine, indeed.
And then press enter.
When you enter, it should uninstall. And then this command here, there should be some result. In my case, it will be slightly different. Because I don't have this home user. So for me, it will be something like...
Yeah, just put a tilde.
Yeah, but it's not in my home anyhow. So for me, it's...
okay. So that command is in, I pasted it again in the chat just in case you join later.
So you should have something as a result of the find command. But in your case, it has to be like something like this. But then it
Okay,
was...
so for example, Olivia, did you try to remove it? Do you still have it a folder there?
Yeah, I tried to remove it. It still had the issues before that. It said like found existing installation, not uninstalling, can't uninstall Xarray, but with find, it finds
Okay.
so
So you can you can remove that folder. Remove rm
Okay, yeah.
-r, and you can remove the folder that you find. Okay,
Okay.
this is for everybody. This is another way to remove the to remove whatever they found. Okay, you can remove that folder. If you use P to remove to not find anything. Okay.
Do I since it's a directory, I can't just use RM.
It has
Yeah,
to do with
remove
-r.
-R. Okay.
And then the -r and then the dir that the found. Put in the chat for everybody.
So after the find comment, so we should not expect to find
Yes.
anything.
Correct.
Okay.
Correct. Yeah.
Is that the case for everyone?
No, for me the uninstallation actually doesn't work.
What did it say?
Kind of says found existing installation and then not installing X-array outside environment. Maybe I can copy it to the chat.
Can you share your screen? Maybe easier.
Yeah, sure. Oh, I need to see which. Can you see that?
Yes.
The virtual machine.
Coming, I think. But it's, yeah, we see it.
So this what I marked is what happens when I run the pip3 uninstall. Then I tried to remove the file, but I wasn't done yet. So
okay, find X-array. You should be able to remove it. One second.
But there, it doesn't seem you have a result, because if you do the find, there's no result, correct?
yeah.
So
I get this, yeah, I get nothing actually. But
there's
then,
nothing.
but then I also, after I did the uninstall, I get the same. So I did the uninstalling again, and then I get the same error with the X-array of 0.16. And also I did this before, and I got it here. So it's there somehow.
Can you run the find again?
For my find, I changed what the path was to match what the path was when it said it had found it in the uninstall.
Home user, yeah, take out the Python.
Just like this.
Because that one is in, yeah.
I get really
enter.
nothing.
And where is it installed then actually? So maybe it's only not when you pip installed it, not in a virtual environment maybe. So it's maybe in your system.
Oh, well then, I don't know. I never did anything else except for the comment.
What was the result before when you tried to pip uninstall?
Oh yeah, I can just do it again.
Maybe one of the two only, like
Okay, yeah.
Then we see
This one.
Ah, yes, look.
Yeah.
You get
user lib Python 3 dist packages.
Yeah. Because then it says I have an existing installation.
So, and if you
Just try to, sorry, just try to remove X-array, sudo apt remove X-array. Maybe it's a problem of a already installed package. Remove.
Like so?
Python 3, sorry, Python 3 minus X-array.
But then maybe when you do an, but then you might also to update it, or maybe try to first, if you do apt dash cache space. So if you do no, can without the sudo.
Oh yeah.
And then apt single dash cache.
Dash, sorry. Single dash.
And then cache.
What do you mean with the dash? Sorry.
That's a minus.
Yeah, it's a minus.
Oh, minus. Single minus. Okay, yeah.
Single minus. And then cache with it, no space.
Like this?
Yeah,
Oh.
but no space. After the dash,
okay.
no space. Yeah. And then no remove, just cache. C-A-C-H-E.
C-A-C-H-E.
Yeah, but the cache it should be together with the apt dash cache.
Like this?
As a single word. Apt dash cache. Yeah, like this. And then space policy.
Policy. No.
Oh, could you write it in the chat maybe? Sorry.
Yeah, policy. Hold on.
Wait, so read first, I guess. Yeah. Okay. Okay.
So 021.
That's okay.
Yeah.
It is compatible.
Yes.
Yeah. You can ignore
fine, but so then the strange thing is that where is this 016 coming from?
I don't know. I checked also earlier that I had the correct version, and it was earlier I also had a higher version. Yeah, but when I installed it, I still get the 016, and I think there were some more people that had that problem.
Yeah, do a pip show X-array.
Like so.
Yeah. And you should get a folder. Yeah, but you still have.
Oh, there's one with the 16.
Perfect. So go inside to that folder in user lib Python dist package and remove the X-array. Correct, Francesco?
That's definitely could be the right path.
There's an error in the lin, so that should be lib.
Oh yeah,
Late
thanks.
Butler.
Oh, there's a lot of.
Yeah, over there. Look, X-ray 16.
Yeah.
Delete both of them.
The egg and the.
Yeah. Both the egg drop and the directory.
Could
There
be
was,
both, no?
I think
Francesco,
this is
both?
yeah both. I think this is a
Perfect.
something wrong in the as you leave.
Should that be removed minus
R.
You said R, yeah.
R.
Okay. All right.
And then probably you need sudo to be sudo.
Yeah,
for
sudo.
that.
Okay, everybody can do this, follow up.
And
And then the other one. Perfect.
May I ask why do we need to press a sudo?
Yes, sudo, and probably is going to ask the name. And now ask again, show, pip show. Pip show X-array should say no.
Oh yeah, sorry. X-array.
X-array. No, pip show
Not
X-array.
found.
Okay.
Package is not found. No, that's what
Okay,
we wanted.
now it's gone. So it's clear for everybody.
Yeah.
So
But
this
we-
is part
we
of
will reinstall
learning
it.
also
There was a question
installation.
in the chat. Is it a good idea to remove it? And actually, we are going to reinstall it.
Yeah. Okay, then I will try to. There it is. There you know it works. Yeah, maybe I can stop sharing and try.
Yeah,
you want to see?
Wait, because
It's good to see if how things are going.
that can be
Okay, okay.
useful for everybody.
Good. And I also, I think, I don't know who suggested the meta most, but I changed the make command to, I think it was about several cores, and I put it only to make, and then it worked. Before that, it didn't work for me either. There are some fatal errors.
Yes, actually, it's something that I was also thinking. Very good, John, that you bring it up. Because in the scripting procedure, there is a make-j that is identified the number of core. And of course, when you have many number of core, then you fill it up the request of RAM from each core. Okay. Yes. So rather, if you don't put, it's going to use, I think the default is only one. It's going to be a bit slower, but will be fine.
Yeah.
So that one, maybe you can share where to modify that option, John.
Yes.
You do the main time.
For example, you could also do -J2 or so, because then you only use 2 cores instead of all of them. Or
Yeah.
just it's a bit slower, but
yeah, open that one.
Yeah, so what I modified, and someone said it in the chat, because now you don't see it, but here there was another another comment that said, I think -J and something else.
Yes.
And I only deleted it, but I also did this for it appears 2 times, so I also deleted it here.
No, that's a good idea. Yeah, it will be a bit slower, but it's you will not run into problems that sometimes your screen can be stuck because all the resources are taken out, and so it can be a problem.
Yeah, that was the case, and I also had some fatal error somehow. It said fatal error, and then
I also tried to install it, and it took quite a long time, and it got stuck on around 78%. And I was going to share my screen and show you, but my command line has now gone completely, it says it's running, but it's now gone completely black. So I cannot see anything. So I think it's also had a fatal.
Yeah, Rosie, try to wait, because probably is using the swap, the one that Francesco was mentioned. So now we see how goes the one from Jan.
How was the exact
Import
name of the
PyGeo.
package?
PyGeo.
Geo.
Yeah.
Oh.
I have similar problem.
Okay, that is because probably the gplib has not compiled correctly. Can you? So we have to.
Can you go up?
Can you
Scrolling
go
up.
up to see if there was an error?
More, you should see red stuff.
Yeah. Doesn't seem like it.
Yeah, but this is from after. It should be in before the PyGeo. It's in the gplib part. Before this.
Yeah, I'm scrolling. That's next.
Maybe what we can do is to can you open the install PyGeo script?
Yes.
And maybe save it as another file name. Okay, and then we can everything above the curl of what you see the gplib, and above the curl.
Yeah.
Yeah, I think probably all of that has been successful. So you can delete everything until top. Wait, no, sorry, and still no. Everything until home, install home.
Up until here.
Yeah.
Stuck. Yeah.
And then and the make dir you also leave. Okay. Now you because yeah, the install. I'm not sure if it's still there. So you do now in the line below, you do make mkdir and then $ install home.
Sorry, in the line here or
yeah,
56?
in that line mkdir.
Yeah.
Space -p space $.
Yeah.
And then install _home, the variable you defined above in capital.
Oh, okay. Yeah, I see it now.
Okay. I guess everything above. Hold on. And now you delete. From line 69.
Yeah.
You delete everything below.
So not 69, but the rest.
Yeah, everything.
Also the curl and.
Yeah, everything until the bottom.
Okay.
Even that last
This
backslash can be, or even the make install you delete, line 69 you delete, and then the backslash after make you delete. Yeah, and then you from line 48 to the top you delete as well.
So also 48 echo. Yeah, I guess it's just wait.
Yeah,
Just
until bash, yeah, until there. Yeah. Okay, can you save this?
Yes. No.
Save it in a different place then.
Not in that folder. Or...
Yeah, maybe in your user home, a home user somewhere.
Here.
No, home user.
Home user. Yes. And just here, I guess.
Yeah, then it's fine. Yeah. And then can you go to a terminal and then just write cd enter? Okay, you are already there. Okay.
Yeah.
And then you execute that with bash and then that file name.
Should I use it as sudo or just bash it?
No, it can be without sudo. Well, yeah, maybe yeah, depends.
Install.
Could be that the home installation directory is not. Well, we can try. We see. Yeah.
Not permitted. I guess sudo maybe better. Or
yeah, probably it's okay. Try with sudo. Okay, can you go to home cd home install and then this geodit with what you see there above?
oh, this one, yeah. Yes.
Okay, now you do cd build. Okay. Can you do cmake space ... Enter.
Permission denied.
Okay, so yeah, sudo then. Okay, can you scroll up if there has been some errors, or is it just warnings?
Warning seems like warnings.
Yeah, how much? No, well, hold on. Okay, seems fine. Go down. Okay. Yeah. Let's try type sudo make. I see there's someone, or maybe some more, but I understand some people are lost here. It's quite difficult as we were anticipating everyone has the same installation, but apparently it's not really the case. So it's quite difficult to follow on what's going on with each of the computers. I've installed it on my computer and it worked, and Giuseppe has it. But then apparently there's some things that are difficult also to guide from remotely. So sorry for that.
I have a very similar problem as John here.
Sorry.
I have a very similar problem as John. I think it might be the default machine or the default settings.
Meanwhile, are there more people where the installation was working?
Yeah, there are just like 4 or 5 people. I think the installation was working. Yeah. And Peter, maybe a solution can be also to create a Docker environment.
That can be indeed, but what I would suggest that we just see what's happening with this installation here. So I guess it might be similar for others, that we can at least try to see what's happening here, and then we'll try to find another solution tomorrow or so. And I will just continue with the presentation and to show what's on my screen, so that we can at least also, for those that have the installation working, that they know what's going on without them really being able to do it themselves. What do you think, Giuseppe?
Yeah, I think, I think that you can run the because it can get longer for each single individual. So you can prefecture, and then we will to work in a self-container. To have everybody but at least you can run the lecture on your machine. You could help me, Peter?
Yeah, I'm not sure if I got what you were. The connection was not so well. Can you repeat that again?
Okay, I repeat again. So you can. I would say that you can go with your lecture and present your lecture, and then we will provide tomorrow. We will provide for next lecture a self-container that they can run without problem, and then they will follow the video lecture and so on.
Yes, yeah, that's fine.
Okay, because it's taking too much time to solve it. Yeah, for each single individual. So be patient, guy. Anyway, this is part also. This is part of also the learning procedure, because when the course is over, then you have to deal with this kind of installation issues. So it's also part of the game. So follow along the Pieter lecture, and then we will provide something more stable for everybody to run the PyGeo. Okay. Okay. So
should I stop sharing?
You can stop this.
Yeah. Hold on, because we're nearly at the end here. Let's see, 94%. So let's see what's happening.
And I'm sorry to interrupt you, but for me, everything seems to be all right from the beginning. I even seem to successfully imported this model, but now when I enter import PyGeo, it writes attempt to perform this operation is not allowed by the security policies. The message appears.
Okay, because here it seems to work. Can you write now sudo make install? Okay, and then the only thing need to be done still now, I think everything is probably, maybe even now the installation of PyGeo was already done. So maybe can you just try to import PyGeo here now with Python 3?
What is the, oh sorry, the spelling again?
PyGeo?
PyGeo, like this?
Yep.
Or, yeah, seems to do something. Yeah, import.
So I'm not sure what went wrong before, because now we exactly did the same thing again, but manually without the script, and it was working.
Yeah.
So maybe that's something, I mean, for tomorrow or so, what can also be, or after the course, what people can try, the participants here, all where it didn't work, is to manually perform all the steps from the install PyGeo shell and see where things go wrong, because we have done here exactly the same as was done by the script, but then and it was working. So that and then at least if you do it in that way, you can also report what was going, where it's got stuck. Maybe there's also, it can also maybe that it's due to memory, insufficient memory, that thing got stuck, and then it tried the next step, and then of course the previous step was not successful, and then therefore maybe things got wrong. I'm a bit in the dark here, so I don't know, but let's hope. At least this is very promising that it worked on this computer, so I would think that it might also work on others. Okay.
When we do this, should we reset anything else? Like some are like halfway stuck in installation, and should we, like, before we do the step by step, should we remove anything first, or?
No, it shouldn't. There shouldn't be any problems.
Okay.
If you're stuck, it could be that things didn't clean up. So if you try to rerun, maybe without being sudo, that it cannot override an existing directory or so. But normally, if you're already sudo, then things should be fine.
Okay.
What you could do is to clean up things, is to clean this home install directory. You see here still on the screen on the left. In this install PyGeo 2 editor, there's this install home variable equals home install. You could clean that up to have a clean installation, or to start from scratch.
Yeah.
So if it's fine, we're going to leave it here, and I'm just starting with a presentation first, and also show on my screen in a Jupyter notebook how things can be run. A question first for Giuseppe. Did you already run things in a Jupyter notebook? Is that something that all participants have done, or not yet?
Yes, so you can. We have been using all lecture Jupyter notebooks, so they are aware how to use it.
You have been pointing them to this PyGeo introduction and PyGeo PK tools. I think today we're going to only use PyGeo introduction, and on Friday normally PK tools. So let's see how far we get.
Yeah, okay. Perfect. So
you can try.
Yeah,
I'm going to share my screen, Giuseppe. So then please ask me to unmute again when I'm have done so. Let me see where this.
So meantime, everybody have the PyGeo _ introduction open.
Oh.
Yeah, okay, I think it should be fine now.
Okay.
And we can see the slide.
With a bit of delay, sorry for that. Let's just jump into it. So we have tried here to install from source. There's also a Docker file available, and so we can use that as a backup if things are still not going right. This is also a solution for Windows or Mac users that are not able to install properly. So that's also an option. First, some very basic design concept of PyGeo. PyGeo is a package, as Giuseppe was mentioning before. It's a follow-up of the tools I've been writing before in like PK tools, but with technology changing and the huge popularity of Python, and also the amount of libraries that are available in Python, we've decided to port everything I've been working on before to Python, so that it can be all the functions that I wrote before can be not only be called from within Python, but it can also use existing packages by building bridges to other libraries, and we'll come to that in a minute. But first, some design concept. In what is very important to understand is that PyGeo works with two different types of functions. One is a method, and a method, for those who are a bit familiar with object-oriented programming, in object-oriented programming, you're working with objects being instances of classes, and you can execute functions of that object. Here is an example. So Jim is an object, so you could say is a variable representing a raster image. Then on that object, you call a function called crop band. So suppose Jim is a multi-band image, and the crop band function or member method here, called, actually it's a method instead of a function, let's call it properly a method. This crop band method is inside the module geometry. It's a geometry method, and we call this crop band on this object. And what happens is that this first band, starting from 0, this first band is being cropped. We take out the first band from the Jim object. And what happens is that actually it has the new, after this operation, Jim has been changed. It has been cropped in place. So Jim will not be the same after we execute this, because we have done something on this Jim object. However, there's also the function when we call the same crop band, but as part of the PyGeo library, we call the crop band as part of the PyGeo library, giving Jim as an argument, as a first argument, and as a second argument, the index number 0. In that case, this Jim is unaltered. It will not be changed, but instead we return a new Jim object that is exactly this first band cropped from the Jim. So the Jim cropped here is a new Jim object with, as a content, the first band of Jim. You see the difference? So before we had a method where we crop a band from the Jim and the Jim is changed. Here, Jim is not changed. It's the same function, but we get a new object which is cropped. Is that clear? This is quite an important concept, and so the whole PyGeo library is built on this concept. So each time you see a method or a function, you know what's going to happen. If you call the method, the object will be changed. If you call the function, you will get a new function, a new object returned. Important to mention, there is an online documentation, so I will share also with you this presentation, and all the links you see here, they're clickable. So if you click on the online here, you will go to the online documentation. There's also an inline documentation. If you type in the command line, in your Python environment, if you type help pygeo.geometry, you will get information of this geometry module, or you can help a function directly by saying help pygeo.geometry.warp, and then you get in your Python environment already help on the warp function. However, if you're online and you have internet connection, I would suggest you use the manual in the online manual, which is far more easy to read than in your Python environment. There's also the tutorial in the online manual. Another important concept that I would like you to understand before we jump into it is how a GIM object, so we're talking about a raster representation here now, we're calling about dealing with an image here, a raster image, and each GIM object can consist of several bands, like this could be band 1 and band 2, and you can go to as many bands as you would like. And this is, each band is like typically a 2-dimensional image. However, you can also have a 3-dimensional image, and we call this third dimension the plane dimension. So in fact, we have, you could say, like 4 dimensions, with the 4th dimension being the bands, and the 3 dimension is a single band. You have a 3-dimensional, or you could call it, as a data cube. In many cases, if you don't deal with the plane dimension, you just have a 2-dimensional image, and even a single band, single plane image. This is just this first part of the cube you see here. If you have a multi-band single plane image, you have a single band here, another band here, and that could be just 2-dimensional image. But just to know, it is possible to work in the 3rd dimension, and that could, to give an example, this could be band 1, a spectral band 1 of a Landsat image, or of a Sentinel image, band 1 and band 2, and the Z plane could be, for example, a time dimension, where you have the first band of the Sentinel image at time 1, at time 2, at time 3, at time 4. You see, and this could be the same Sentinel image, but in another spectral band, being also acquired at time 1, time 2, time 3, time 4, and so forth. So if this is more or less clear, let's go to a real example in Jupyter Notebook. I'm going to stop sharing and then restart sharing. So Giuseppe, please be ready to unmute me. Okay, so you all see this screen now? Okay. So here what I'm doing is I'm importing some libraries, some modules. Don't mind, there's some warning here that's about some older version of Pandas, which is not important here. So we've imported some libraries, but most importantly here for this course, there's a last line, we import PyGeo, and I call it PyGeo imported as PJ. So from now on, we can use the PyGeo library, and instead of writing PyGeo entirely, I can just write PJ, and that will represent the PyGeo library. As I mentioned before, this is this help we had already, so you can have inline the documentation on the warping with all the parameters that exist. But again, I think it's much easier to just go to the online documentation. So let's see what's happening if we try to open an image. You create a new GIM object, which is our object that represent the raster image by saying pj.gym. So this is our class representing a raster image, and we give as an argument a file to a path, and this path can be a TIFF file, for example. Once we have done that, we see that this image is being entirely read into memory, into Gym, and we can query some of the properties. For example, we can have the property, the number of columns, or for example, the number of rows, and we see it's a 600 by 720 image. What is also important is that by reading this GeoTIFF, there is also the georeference, because it is a GeoTIFF. It has been georeferenced, and there is also a projection linked to that TIFF file, and that projection you can see here. So it's a Latlon in EPSG 4326. So it's an important design also of PyGeo, that all the information you need for the georegistration is already contained in the object. It has also a geotransform. The geotransform is also, it's written here what exactly means, but it is to position your image within the projection defined here. So it defines an array with 6 items, being the top left of the first pixel, the resolution in east west. The rotation is normally 0. Then it has the top left position in Y, the rotation again 0, and then the north-south pixel resolution. So you see here, this is in degrees. Resolution is in degrees, and this is the location in X and the location in Y of the upper left pixel. So from all this information is contained in this GIM image. As we have seen before, there we can have multiple bands and we can have multiple planes, but in this case, this was a simple single band, single plane image. So we see that this has only one band and only one plane. What we can do, however, is open a second GIM. Now, this time I'm not calling it GIM, but I'm calling it GPP, sorry. So from this moment, I have a second GIM object called JPP with the content of this image. And what I can do is stack this image on top of my existing GIM, calling the member this method stack band. So now GIM has 2 bands. See here, number of bands 2, because I simply added by stacking this image to the existing GIM image. And now, as you see, I'm calling the member method, the member function, so the method stack band, and GIM is indeed has been changed. So as an exercise, but as not all of you have the PyGeo installed yet, I will do it here for you. Those who have it installed can maybe think of their own. But let's try to use the stack band function instead of using the method, so that we don't change this GIM object. So we had this GIM, and we want to stack the band. So what we can do is we call pygeo.geometry stack, and we give the GIM as a parameter, and then the other GIM JPP as well, and this will return third Gym object.
But now it would have 3, no? Because Jim we already added it.
Exactly. Very good observation. So now Jim stacked as how many bands? 3, because Jim was already changed before by this command. It had 2, and now we stack this one on top of that. However, the Jim has not been changed now anymore. The Jim still has the two bands we saw before. See? So this is the difference between calling the stack band as a function where we give Jim as a parameter, or calling the stack band on this Jim where Jim is actually changed. So I hope this concept is clear. Otherwise, please interrupt and just ask, because this is quite important for also for the remainder. Something that has that I've added since last year, I gave the course last year, and something that I've added is to label the dimensions, because what you've seen here is that we have just a number of bands and a number of planes that can be named, that are just numbered from 0 to 5, or to whatever number we have of a number of bands, but we can also label them. For example, let's call those bands for Jim, call it ET and GPP, and let's call the plane, although we only have a single plane, but let's give it a timestamp. So this timestamp, let it be the 11th of August 2019, for example. And by giving these bands a name and these planes a name, we can label them by setting the dimension with a dictionary, a Python dictionary, being for the band we use band names, and for the plane we use plane names. So if we then call the dimension of what are the bands, we get these bands and the planes, and from now on they're labeled. So what we can do here now is we create, again, we are using the function here, we are creating a new Jim object called Jim1 by cropping the band, but just using the index, the numbered index, not using the labels. And we see that Jim1 will be a new Jim object with the second band, because we're starting from 0. So that will be, the second band will be contained in Jim1, the second band being this GPP. But what we can also do here is do exactly the same thing, but instead of calling the index, calling the label, let's say crop band, and which band? The GPP band, and we create this in the GPP Jim object. And then we can see that actually the Jim1 and the GPP are exactly the same in pixel content. And what also is happening, once they have been labeled, these labels are preserved. So we have cropped this first band, the GPP band, and so you see indeed that the band now is no longer ET and GPP. It now has only this GPP as the band label. And the plane has been unaltered. It's still this single date. Any questions so far? No. Just please interrupt if you have any questions to ask.
Peter, and then of course you can call it directly using the GPP labeling, correct? You can call it directly one single band using the GPP labeling. Okay, I think my connection is very slow, but it's fine. I understood very well.
Okay, yeah, I'm not sure if I understood the question, so but you can, I mean, it has been, so here we didn't have to name it because it was already named here, so we just cropped it here and it retained that name. What if the question was, you can also you can rename it, of course, or you can just name a single. If you have a single band, you can also name that single band, as we did with the plane, that we had only one plane and we can name it that way as well. But so I'm not sure if that answers your question, because I'm not sure if I understood it. But if it's all clear,
perfect. Thank you.
Okay. So let's now work with multi-plane images. So remember, we can have a single band, but we can have multiple bands, a multi-band image. And so what we have now in GIM, we have two bands and one plane. We can revert things by calling band to plane, and what's happening after that is that the GIM object will be reorganized geometrically, and the bands will be planes, and the planes will be replaced. So that means that after this, we have two planes, and the names of the planes have been retained, and we have no band anymore. I mean, we have a single band image and two planes. Notice that the band hasn't been named, so it could be that this plane name is it doesn't make sense maybe to have it as a band name. But I prefer not to name it. However, when we say band to plane, the names of the band will be in the plane dimension. One reason you could ask, why are we doing that? One reason is what is typically the typical use of this multi-plane images, as I mentioned before, is it could be a multi-temporal image where for a single band you have multiple acquisitions for different times. And what a very common operation in remote sensing is to reduce the plane to create a composite. Suppose you have 5 acquisitions in a row, and a number of the pixels have been cloudy, and you want to get the maximum or the mean or the median or whatever type of composite. There is a function called geometry. It's in the geometry module, and it's called reduce plane, and you can give a function, a rule, how to composite should be created. So in this case, if we call you, so remember here we have 2 planes, the ET and the GPP. So so here it's a bit strange maybe that we're going to calculate the mean between the 2, but suppose there have been like 2 different acquisitions and we want to calculate the mean between those, and this function is available on the planes. So if we want to do it on the bands, we first have to go from the bands to the planes dimension, and we can call reduce plane on this GIM.
A quick question, if I may.
Yes, please.
So the band to plane function or method, it just swaps the bands and planes, right? We don't lose any, or okay. So if we had multiple planes in the GIM object before, we would have then multiple bands after the swap, right?
Well, that's a good point. Actually, you should be careful with that. The normal way, if you already have a multiple plane and a multiple band, it might not be the best thing to do here. What is actually meant for is that if you have a multiple band and you want to convert it to multiple planes, this is what it's used for. And a typical usage would be that you open a multi-band GeoTIFF image, for example. Some of the GeoTIFFs are already stored on file as multiple bands. When you read those, you read them as a multi-band image, multi-band GIM. And suppose you want them as a multi-plane, you can convert them with this command band to image, band to plane. But it is, in general, it's not a good idea if you already have multiple bands and multiple planes to start playing with those. Then it's better to first create another image that is only a single plane. But is that answering your question?
Yes, and I assume there's then a command that if I have such a GIM object with multiple planes and multiple planes and bands, I assume there's a command that like strips them apart so that I
Correct.
have. Yeah, okay.
Correct. Yeah, cool. That would be called then crop band and crop plane.
Oh yeah, fair enough. Yeah, yeah.
Okay, I think we'll cover that in a second. You see here, it has been created. So the GIM, a question here for you, anyone. What would be the dimension of GIM mean? How many planes it would have?
Just one.
Just one, indeed, because it's reducing all the planes, taking the mean of all of them, and giving as a result a single plane. It will have the same amount of bands as the original because the bands are not touched. It's only the dimension of the planes that has been reduced. Okay, good. You see here there's a runtime warning saying there's an overflow encountered. So where does it come from? And to know where it's coming from, let's have a look at the statistics of the GIM image on which we reduce the plane. You see that when we call it, I mean, there's many statistics you can do, but without any parameter, it will just calculate the mean, the max, and the minimum. And we see here that the minimum in effect is like another number, like an infinite number. And you see that also when calculating the mean, it will be a bit problematic dealing with this very overflow type of another numbers. So what we will do, and you see immediately here also, it's interesting to see what can be done with the GIM images. We will top off all the negative numbers. So let's say we want all the pixel values that are negative, we want them to be 0. And this can be this can be done in this Pythonic way. And those of you who are familiar with NumPy, they would immediately recognize that this way of working. So we say from the GIM object, I want the pixels that are negative, I want to assign them to 0. Okay, so once we have done that, let's try it. Let's calculate it and also calculate the statistics. So once we've done that, we see that the minimum indeed now is 0. The maximum hasn't been changed, and now we get a decent mean value because it doesn't have to deal with these overflows. And this is exactly where this was coming from. So if we do this again, calculating reduced plane on the GIM, we see we don't have this nasty runtime warning anymore. Of course, we have to keep into account that we have changed the image, and maybe this is not what you wanted. Maybe you wanted something with these other number values, but then this is another story, how you can deal with those other numbers. There are several ways to deal with them. You can either assign them to a specific flag or a number, and then you can reduce the plane with setting a no data value, or you can do it in the NumPy world with working with other numbers. But that's maybe a bit too far here for the introduction I would like to give now. Any question on this compositing? No. I would like to maybe for now skip this part here, so because maybe I come back on it at a later moment, because we might run out of time, and also it's maybe a bit more advanced than for first introduction. What I would like to show you here is, hold on, let me just check if I maybe have to check some in the presentation. Okay, now I think I can tell everything here what I have in the presentation. You can use the presentation for later as a reference, but I can go through it here now. A very important concept, and actually, as I mentioned, one of the reasons why I've ported PK tools to PyGeo is because an entire new world opens once you are able to connect your data model to the NumPy data model. So this was something I had to implement at the core of the C++ library in PK tools on the data model. But once that was done, we can use a large number of packages of modules in Python that are all based on NumPy, and actually by extension not only NumPy but also Xarray, and we'll see that later as well. And the only thing you need to do is on your gym object just call the member function, the method np from NumPy, and you will see that once you execute this, you get the NumPy representation. You can get a NumPy array from all the pixels in your gym. And actually, we get the best of the two worlds here, because as you know, the NumPy array does not have any geo information. We are losing the geo information. So in this array, we don't have anything like the projection and so, but in our gym, we do have it. So here, by just calling np from gym, we have the NumPy array, and we still have everything in the gym as the geo information. So you see here indeed that when we call the Python function type, we see that gym.np is nothing else than a NumPy array. And the nice thing is, as I mentioned, once we are able to do that, from now on, we can also call all the NumPy functions. So let me first execute. I have to come back to this. I wanted to skip this, but now it's getting back to me. So I need to. So what I was doing here, there are a number of reduced plane predefined functions like the minimum, the mean, and the max, and so forth. But we can very often you want to create your own composite rule. So this is done by what I call what is known as a callback function. So you define a function here called getMax, and it's returning the supremum or the maximum of two images, and we call this getMax function as an option, as a parameter of our reduced plane. And so once we call this reduced plane, it will return a new reduce image, so where all the planes have been reduced, and this gymmax just contains the maximum plane of either gym and sorry, it has to be some gym and yeah, sorry, this multiple planes in gem, it will calculate the maximum plane and store it in this gymmax. So once this is done, of course, we have a single plane image.
Sorry, quick question, if I may.
Please.
Above, you called this reduced plane mean with quotes. but with your own user-defined function, you didn't use quotes. So so is mean like a pre-defined function of this reduced plane?
Correct. Indeed.
So we could have used quote and then whatever the mean function of Python or NumPy is. I'm not too familiar.
So this, if I understood your question correctly, what you ask is why is there a quote between mean here? Because here indeed it's not a function, it is a name of a predefined function that is already implemented in reduced plane, and there are not so many. There, if you would to consult the documentation, you would see that apart from mean, there is minimum, there is maximum, and maybe a median. I'm not sure, but I don't remember. There's not so many of predefined functions. If you want to other functions, you have to create your own. And in this case, it's not a name anymore. I mean, it's the name of a function. And here it's really this function we defined ourselves. If I would use here getMax within quotes, it would try to search for the predefined getMax in this reduced plane I implemented in C++, and it wouldn't find it. So it would complain. So what we do here is create a new function without quotes. So actually a real function, and now this function is actually executed within this reduced plane function.
Yeah. Well, in the case of mean, I think mean is a function in Python as well, right? So it probably would work.
Yes, but the thing is, here this.
Oh, no, it's more complicated than it's
a
the
bit more
HI.
complicated.
Yeah, I see now.
Actually, you have to define the function as this. The function here it expects a function with two GIM images, a GIM object.
Yes.
And so it would be indeed a bit more complicated than that.
Got you. Thank you.
Okay. So once I have done this, I'm not sure if I did this already plain to band. Let's see what I have. Okay, so I have band names. I have a single plane, single band. Fine. And let's see here what happens. So I was, just to recapitulate, I have two reductions performed. I have a GIM mean, which contains the mean of the two bands I had before. So this is GIM mean. This is GIM max, which is exactly the same reduced plane, but now getting the max. So what we should expect that this GIM max is at least as large for each pixel than this GIM mean. Are you with me?
Yes, Pieter, yes.
Yes? Okay. So what we can do, and I want to show this, how we can use this NumPy, is by saying let's calculate in the PyGeo world a new PyGeo image, calculating for each pixel the GIM, seeing it will compare the GIM max with GIM mean, and actually it will for each pixel have a 1 when it is true and a 0 when it's not true, and it should be never true because GIM max should be always at least as big as GIM mean, so all the pixels should be 0. So we can do that, then check it in several ways to see if all the pixels indeed are 0. But let's try to do it in the NumPy world by converting this result to a NumPy array, because this will be the result here between the brackets is a GIM object. We make a NumPy object of it, a NumPy array, and on that we just call sum, meaning give me the sum of all the pixels in all the dimensions. And we see indeed that the result is 0. So here you appreciate that we can call a number of numpy function. We can call any numpy by first converting our gym object to a numpy array. And there's many other examples as this. I just use this here now as a sum, but there's many other examples. Well, let's see some others.
Sorry, another question. When you make this comparison between max and mean, in the gym environment, are those booleans or are these zeros and ones?
Very good question. In the gym environment, it's 1 and zeros.
1 and zeros, okay.
In the Python environment, often it's a boolean, and this is different. I prefer to work with zeros and ones, but that's something to keep in mind. That's a very good point. It's zeros and 1 here, and it will be a byte image.
Mm-hmm. Perfect.
Okay. Let's see what we can do also with a gym object. Here we're using a Pythonic way of accessing the pixel values. So what is done here? We can access the first 3 columns and the first 3 rows of a gym object. And most of you might know already this from NumPy. So I'm sorry, I'm not sure all of your background, so I'm not familiar with your background. If you have programming experience in Python or in NumPy, sorry if I take sometimes things for granted. If you have any questions, just interrupt. It's not a problem at all. But what I also don't want is that I start to explain too many things that it might be boring for some that already know things. So if it's not clear, just interrupt and I can explain. So what this does here is it takes the first 3 rows and the first 3 columns, but it returns it as a gym object. And actually not only a gym object, but really a gym object in the sense that we still have an image that is with geometry information. So if we call the bounding box, for example, of that, this is now another image, this is the last 3 rows and the last 3 images, the bounding box, it has a bounding box, and it actually corresponds to the real bounding box of that image, so of the last few pixels of that image. And if we are interested in really not showing like this that it's a PyG object, but we want to see the content, we can just go back to the NumPy world and say, I want to get the NumPy array of these first 3 pixels. And you see here, this is the content of that image, but then in the NumPy world to just display it. And this is the way we can access, it's called get items, because nothing is changed, nothing is set, we're just getting the information, getting the pixel values. Similarly, you can also set items by doing exactly the same, but now saying, I want the first 3 rows and columns set to 0, and then once I've done that, I want to show, by going to the NumPy world here, showing the first 5 columns and 5 rows as an array. And you see that indeed the first 3 rows and columns have been replaced by 0, because that's what I've done here. And then I show the first 5 here. So now this is a way we can just play with the pixel values in a very simple Pythonic way. And now our gym object has really been changed, and we can just, if we want it, we can just save it to disk as well. So this is another a big difference with the pktools world. In pktools, everything was done in bash and file based. So if we had 5 operations in a row, actually what we were doing is we had to read from file, do an operation, write to file, open again, write again, open again, and do all these operations. In NumPy, the nice thing is you can do all these operations in a row, or everything in memory without having to read back and forth and write to file, to disk. So let's see, can we also display this image in a Jupyter notebook? Yes, we can. Why can we? Because I don't have to write anything, any programs for that. I can just use everything that already exists in the NumPy world. What I have to do is just do as if I had a NumPy array and display this NumPy array by calling the NP function of my gym object. So when I call this, we have here the gym object shown. This is actually this content we have read from disk here in the beginning. We see here. So this is this image here. Let me just quickly check how we are doing with the timing. We were supposed to have a coffee break, which I skipped. Sorry for that. And we are at what I would suggest is we are at about 1 hour. We still have. So if it's fine for you, let's have a 5-minute break. Let's say up to 6:45. So a 7-minute break, and I'll come back to you. Is that fine for everyone?
Perfect. Thank you. Yeah.
Okay. See you later at 6:45.
Okay. So at 45.
A bit, and it seems this meeting is being recorded. It seems that says in the this meeting is being recorded in the installation. Is that correct? Were there some people now managing?
Yeah, I think some manage, sort of.
Okay, maybe let's see how far we get here with this notebook here, and then maybe at the end we can still have some discussion, as I think we're back on track on because if there would have been more already executing, I would have maybe taken some more time in the exercises where I now just do the demonstration instead of really hands-on. I think that maybe just as before I continue, this is a general comment on the way I think a hands-on course is very good and probably preferred. But my experience is that it's quite hard, especially on if there are many participants and online, because you cannot really go around and check for where things are going wrong, and especially also here when not everyone has the installation ready. So let's see how far we get today and also tomorrow, and then hopefully maybe on Friday we can have some more people that have it. Okay. Is my screen still shared, by the way?
Yes, Pieter.
Yeah. Okay, so where were we?
Yeah.
So I was saying that by having this NumPy representation of a gym object, we can use the functions, for example, also to display the image in Matplotlib. Another thing is what we can do is there's many scientific libraries for NumPy, and so what we see here in this example, we're using the median filter that is defined in SciPy. So SciPy is a very powerful package that is working on NumPy arrays. So what we see here, so if I import the ND image, which is an image processing part or module in the SciPy package, if I import it, I can call the function median filter on my gym array, because I'm just exchanging, replacing my gym with gym.np. So from this moment, we are in the NumPy world and we can execute functions on this NumPy array. So I call the median filter with a size of 5, and the result will be stored in the NP image. Okay, so let's do this. From now on, we have an NP image in a NumPy array. So you see that this is a median filter. This is a different version of what you see here in much more detail. So it has been all blurred because we have been using this median filter on a 5x5 in a 5x5 kernel size. However, the way I've done it here is what I get in return. It's a NumPy array, so it has not the geo information. We have lost it because what this we are here purely in the NumPy world, and I don't have a georeferenced image. So let's try to solve that. What we can do is, first of all, I want to show you that indeed we have lost the geo information. Luckily, there are ways to solve it. First of all, what we will do here is we can also go back to the gym world by calling from the PyGeo library, calling as we were doing with .np for gym. Now we call np from numpy to image, and we give the numpy image as a variable, as a parameter. So we can convert a numpy image into a gym array, into a gym object. However, the problem of the coordinate reference system is not solved. Of course not, because how would the PyGeo know what projection or what things to use for the geotransform or for the projection, because it's nowhere written in this NumPy image. So in this NumPy array, it's just a NumPy array without the actual georeference content. So it cannot know it. So this is all empty. We can fill it by saying, this normally is an exercise, but let's do it together. We see here there's a set projection and a get projection, and there's also a set georeference or geotransform and a get geotransform. So what we do is we say from this a gym, we set the projection and we copy that projection from our gym image, because we still have that gym image, and we know actually that the georeference should not be changed because it's exactly the same dimension and the same image, the same projection. So let's call here the set projection on a gym, and by copying it from gym, get project set projection. What is here? Takes one to a given get projection. Sorry, that's without an argument, of course. So, and we do the same thing because to have the full coordinate reference system, we need to have both the projection and the geotransform. Once we've done that, at this moment, we have a full defined gym object with as a pixel content the NP image, but which is also georeferenced. So this is possible. However, things can be done more easily without all this copying, and in the following way. There is, in the NumPy world, there is a way where we can do things in place, because what is very important to notice that this was like, as you were saying before, as in PyGeo, this is the functional way. So we give a NumPy array as a parameter, and things are not changed in place. This gym object is not changed. Instead, it is left as it is, and a new NumPy array is returned. The same as we were doing with in the gym, the PyGeo world, by using the functional way. However, there is a way, and in the NumPy world, they're not doing it as we do in PyGeo. In PyGeo, we're using the member function. What the NumPy world is doing is it's calling exactly the same this and the image median filter with the gym NumPy representation as an argument, but we can set the output being the same as our input. So here we define, we say we don't want the output just returned. We also want we want to define our own output. We say, please copy your output in this NumPy array. And by setting it the same as the input, our gym NumPy representation, it is actually our gym that is being changed in place. When we execute this, both a new object is returned, but also the object is actually stored in our gym array. So from now on, and we don't have to set any projection because our gym still contains all the projection and the georeference information. It's only the pixel values that have been replaced by the median filter. So this is one way to do things. There are other functions that do not have this in place output way of doing things. So suppose we are using a NumPy function that does not have this way of working with in place. As an alternative, we can do the following. We can use our previous function as before without defining the output. We say here, we call ndImage median filter on our gym object, which will normally return not the gym object, but will return a NumPy array. And what we do here is we use the set function of the NumPy. We say we want our gym NumPy representation, but we want to set all the pixel values, the real content, we want to replace it with what you have been calculating here. So here you can, in this way, replace the pixel values of a gym object by a NumPy array. So actually, if we execute this, of course, what will happen, it will be a 2-time median filter because as we have done here, our gym was already replaced with the median filter output, and now we're doing it again. So there will be twice a processing of the median filter. Any questions so far?
In this way, Peter, we are going to use it. We are going to avoid the use of every time a new memory, because we are not storing many objects. We are just rewriting.
Very good. Yeah, very good. So this is exactly the reason why this has been done. And because you could question, why are you having this difficult way of representing or doing the functional way and the method way? And this is exactly the reason, because if you always use the functional way, you always return a new object. And if you're working with large images, each time you return a new image, it's exactly the same amount of memory that will be duplicated and duplicated. And by using these member functions, these methods where you do things in place, everything is overwritten in the same object, and you only the memory footprint will be limited to only what you have here. And this is also done in this way using this in place function. Correct. So that's
okay. Yeah, very good.
very important observation indeed. Then a last part I would like to share with you is a very important new type of library. Or I mean, new is it's not that new, but it's quite recent, still much more recent than the NumPy array, and that is X-array. And what X-array does is what I was trying to do before with the PyGeo, is that I wanted to combine the two worlds of NumPy array with the geo information, because that was not existing, and the NumPy array did not have that. But then X-array came, and X-array was doing exactly the same thing, but with much more as well. But it was combining the strength of NumPy arrays with the labeled dimensions, with the geo information. So an X-array is an object that at its core has also a NumPy array, but it contains all the information you have in a real georeferenced image. And actually, there's a lot of new libraries coming as well for X-array, which made me also create a bridge from GIM to X-array. So everything you could do in X-array, more or less, you can also do in PyGeo by using this bridge. Instead of NumPy, we just then say gim.xr to have a representation of GIM in the X-array world. And you see, actually, this was also one of the, I mean, I was using this labeling. This was the reason also why I was using this labeling for the band names and for the plane names, because X-array is actually also using this type of labeling. And the nice thing is that when you have defined the labels correctly in GIM, or when you have labeled them, you can use an X-array without having to label them, because the labeling is automatically done for you. And the opposite is also true. Now, instead of, we can also create GIM objects from an X-array, and we don't have to care about the geo information, because as it is already in the X-array, it is automatically coupled. So what we did not have in the NumPy world, there was no geo information, so we had to copy it or deal with it by copying it from another GIM, or by setting it by this set projection and set geotransform. This is not needed for X-array, because X-array has the information. As you see here, it has some attributes, it has indexes with the X and Y. It has the data variable name, ET, as we defined before. It is also three-dimensional, so it has an X and a Y, which is our two-dimension in our cube, and it has a time dimension, what we call planes in the PyGeo world. So it is a data cube in X-array is a one-to-one mapping, more or less, to our GIM object in a multi-dimensional and multi-plane, multi-band and multi-plane GIM object. Well, the multi-planes is represented by the time. It can be, now we only have a single plane, but if we have multiple planes, there can be time like 5 or 10 or 100. And what we have with the bands, these are called data variables in our X-array data set. So we have one data variable, which is called ET. If we would have done the gim.xarray based on our multi-band image we had before with the GPP and the ET, we would have got two data variables here in our X-array. So just to prove here that we actually can go back and forth, we go from a gym array, we have the gym array, we create an X array from gym, and here we call X array to gym again. So we go back and forth from a gym to an X array and from an X array to gym, and we create this gym, a gym, and we see that actually the projection and the geotransform are still retained in this a gym, so nothing is lost for the information. What we did have the problem, the problem we had in NumPy is not the case anymore. So this is very powerful, that we can even better use X-array than NumPy once the functions are available. And indeed, many of the NumPy functions that are available on NumPy arrays are getting more and more also available for X-arrays. And here, to show you that very similar to PyJ, also at the heart of an X-array, so if we call gym.xarray and we call this data variable et, and we call the data itself, we see that the type is hidden. The hidden type of it is actually nothing else than a NumPy array. So the X-array is like what you could call like a wrapper around NumPy array, where all the information like geotransform and projection is also contained. But at the heart of it, the real data is a NumPy array. Any questions? No? Okay.
Yes, Peter, in
yes.
terms of speed between X-array and NumPy, is there any difference?
There is sometimes. It's in many cases it will not. In some cases, as we will see here, it is. And I must admit, I don't really know why, because there is. Okay, here probably it's due to the fact that there is another function. It's to calculate the median as the filter we had before. I can call this function here a roll, which is called, I call it on the variable et. It's a rolling like a kernel filtering function, both in the x and the y direction. The kernel is centered, and the result, and I'm calling the median on it. So it's a bit different than just this median filter we call here, but the effect will be similar. And in fact, I'm not going to execute it here because this one takes several minutes. So this will be much slower than the plain, the pure NumPy implementation. However, I think this is due because of the function that is actually different. If we, there are many functions in X-array defined that are just under the hood exactly the same as the NumPy functions, and then there would, in principle, not be any difference in speed. On the other hand, what is very powerful in X-array is that X-array has an implementation or it can be coupled with what is called Dask, and Dask is a very powerful way of dealing with very large arrays by splitting it up into tiles or into chunks, as they call it. And even better, you can in a multi-core processing environment or in a cluster environment, each of these different chunks can be executed in parallel, and then they are reduced back again into a single large array. And in that case, it will be much faster than a NumPy, because you can take profit of this of a cluster of multi-core parallelization. So this is a thing that is where X-array will be actually more performant performing than NumPy. But that you have to know that this is just come on top of it. At the very heart of it, it's just a NumPy array. Okay. What also, I mean, what the nice thing also, and I will just copy it here just to show it. Let's see the gym. What I'm doing here is I'm calling the X-array representation of gym. I'm plotting the ET variables, so the ET band, and then plotting it. Under the hood here as well, it will not do, it will just do matplotlib, so the same functionality as we were seeing here. But instead of having to do these things, X-array has already a wrapper around this matplotlib, which allows me just to do things like plot. And in addition, you will see here that where I was getting just the pixel coordinates from 0 to 700 and to 600, what was it? 600 number of rows, columns, and 700 number of 20 number of columns. Actually, what we see here is when I do the visualization in plotting, I get the real coordinates in the coordinate reference system defined of the image. In this case, it was latitude, longitude, and you see it's actually the X and the real X and the real Y. So this is a very nice function of X-array, that it will show you not only the image but also the coordinates, and you will have this nice legend as well. And you see here the time of the, so this is the time dimension. If we can show that maybe later on, or maybe in Matera, I can show you some example. If we have a multi-plane images, multi-plane image with several acquisitions in time, we can just convert it to an X-array, and then we can even show all these different times in different columns, and it will show you the timestamps of all these planes. As you remember, we were setting the time stamp for the plane as the 11th of August 2019, and so you see here that it is all nicely retained when we are calling the X-array representation, and it's knowing exactly about what time this is. So all this information is just can be going back and forth between PyGeo and X-arrays. Okay, then a few words more on the on another object of PyGeo, and this is instead of gym was representing arrays, raster arrays. There is also something like vectors, and this is called gym-vect, and we can have a vector opened just the same as we were doing with a raster. Instead of pj.gym and then the file name, we can now say sample equals gym-vect and then the file name. So this is the polygon that I think Giuseppe has defined. And again, I'm creating a bridge between the PyGeo world and now in this case pandas. Pandas is a very powerful data structure, from defined in pandas, and we can go from the vector contents, all the features we have in that vector, we can display by saying first going through the dictionary representation of my vector, and then creating a data frame from that. So the bridge I was making, I was creating a bridge through a dictionary so that all the features can be, let's do that here. So you see that when I call sample.dict, this is, so this is a dictionary of the features I have. So without the the coordinates of the polygon, but just the content of the feature contents of the polygons, and I can create a data frame from that. So this is a very simple data frame with only ID 1, 2, 3, but you can have much more complicated data frames with many features, content, and they all will be can be represented as a data frame as well. There are also other examples where we can go from GymVect to GeoPandas. GeoPandas is an extension of Pandas, but where you can retain all the actual polygons as well, not also in the geographical content. But I was also seeing that, so only at the last moment, that I think GeoPandas has not been installed, if I'm correct. And so I was not having this in this demonstration here. But it's also possible, and you can read more about also in the documentation of PyGeo. There's some examples how you go from a PyGeo vector to GeoPandas. Then one more thing I would like to show you is something that is quite often used, and I think Giuseppe has shown you some examples also in PK tools. It's one of the tools that is most often used, I think, from PK tools, and that is to extract data by overlaying a vector on a raster and extracting the pixel data that are below all these features from the vector. This is called extract. So what we do here, we have our gym image from before. We have our sample, the 3 polygons defined over the image. As an output, we are creating a new PyGeo GymVect object in GeoJSON format, but we are doing it entirely in memory. And the way we do this, instead of creating a path on disk, the absolute path name starts with VSI mem, which means that it's a virtual disk path, and this disk we can refer to later in this processing, but it will be entirely into memory. So nothing is really written into disk. It's like dealing with a file name, but actually dealing with all the content into memory. So if we do this extraction, now this extracted is contains all these 3 polygons, but for the pixels inside these polygons, it was creating the mean value of the pixel values beneath and putting that into extracted. So to see, as we were seeing here before, we can see the content by going through the pandas data frame. Exactly, you see the same IDs as before. So there are 3 polygons, but now there's a new feature, new field added for each feature. For the feature ID 1, this 4.2 is the first band we were reading in Gym, and it's the mean value of all the pixels in that first polygon, and the same for the second polygon and the third polygon. If our Gym image would have been a multi-band image, there would be also B1, B2, B3, B4, and those values would also be contained. Similarly, if it would have been a multi-plane image for, let's say, like a multi-acquisition for multiple times, you would also have all this information here. So this shows you how you can extract pixel data by overlaying it with a GIMVect vector file. I've been rushing a bit through all the information. I would rather save the next presentation, the next for Friday, stopping the real demonstration here. I'm all available now, so we can discuss things and have some questions, or maybe go into some details on the installation now. Because what we'll be dealing on with on Friday is I think correct me if I'm wrong, Giuseppe, but I think you have done the PK tools exercises already, have you?
Yes, we have done like 3-4 weeks ago, and
Okay.
so but I can point to again to as a refreshment for all you guys.
There's no
This
need
way
to
Peter
refresh.
can go from there. Yeah,
There's no need to refresh. What we'll do exactly that on Friday. So what I would like to show you there, especially for those who have been working, or Giuseppe also seeing presenting these PK tools, I will go through exactly the same exercises, doing the same things, but then both in the PK tools and in the PyGeo world, so to see where things are different, and to show you that the same things can be done, but then in Python. So I would like to keep that for Friday, not starting already here, if that's fine for you, and then let's see if we can discuss things. If you have any questions, or maybe deal with some problems we have with the installation, I'm all open to your suggestions.
perfect, Peter. So this is the last function that you show, that you extract the polygon information, can be done also where sample is a point information, of course, I think, no?
Yes.
Isn't it? Yes.
Correct.
And you extract, because we were dealing, so this one is another way to do it, the same kind of operation that GDAL location info was doing.
Yes.
So, and then it's going to be also, because this is something also that me and Francesco, we were working in these days to do, because this is, as you know, this, as you know, I can imagine, this table is very important when we are going to do a modeling procedure. Because at the sample point location, we have a table with our Y and the predictors, observation and predictors. So we can build any kind of model. And are you aware of any kind of way to predict the model back to the image? Because what I was using is an external library. I think it's called very fast. It's actually extremely slowly. So if you have something, also it's something that you can add.
Yes. So
you can add for the
so
next
it
slide.
was already.
I mean, 1 or 2 lines.
Yeah, I think it already exists for classification models. I have it works. So if you, let's say, you
yes, I
train
can give you the name.
classification and you want to infer it into and write the results in an image or in a vector, that already works. I think you are referring to a different, all types of models, right? Regression or any type of other model, not just classification.
No.
Is that correct?
Yeah, I mean regression or regression or classification.
Yeah.
Any kind of modeling that you do a prediction on the table, then you should be able to do the prediction also on the raster. And what we were testing with Francesco was the one set of it is coming. It was the use of.
Are you sharing your screen? Or
library? No, I'm just checking the name of the library that I don't remember. My yes, now is loading, and this library was is working, but is very slow.
So what I've
So
already
I
done,
was
and what is-
checking with you if there is another way.
So what I was using already is exactly this bridging with NumPy. So I've shown you with the median filter of NumPy, the SciPy has also a very powerful machine learning. You have this scikit-learn and SciPy. They have modeling and machine learning capabilities in that. And so once you are using those, the way I was showing you how you can fill a PyGeo gym object with the content of a NumPy array, you can do exactly the same for scikit-learn and writing your result of your model in an image in that way.
Okay, so yes, PySpatial ML. PySpatial ML is the Python. Yes, is the Python library that we were testing with Francesco for the prediction, for the predict a skylearn model back to the image, and
but
it's very slow.
Working with NumPy arrays, Giuseppe?
It's working directly on the raster. So you load the raster directly, and they do the prediction on the raster directly. I can share my screen if you like.
Yes, hold on.
So this is something that we will present next, but I can make a. So actually, in particular for
we cannot hear you, Giuseppe. It's the connection is very bad. If you also share.
Can you see my screen?
We see it, but we don't hear you. It's very slow, the connection probably.
You can see everybody.
Giuseppe, we lost you. Did we lose Giuseppe?
Yeah, it seems like it.
It seems like it. So we can wait until Giuseppe is coming back. Maybe meanwhile, is there any some other questions or things you want to share or know? Was everything clear, or was it? Could you follow? Milutin, please.
Hi, yeah, thank you very much for the presentation. It was very nice to see the OpenGeo, how it works. So I was always interested to learn it. And I particularly like the last command to take the samples. And can you please explain a bit more about performance? So is it fast? You know, because there are also alternatives like Python libraries that are doing the same thing, but they are usually very, very slow. Yeah, and also, if can you comment the performance with respect to command line tools? Yeah.
Yes, welcome back, Giuseppe. We lost you, but you probably know it. We can go back to your question, but first let's. There was a question from Militin on the performance of the extraction. It's difficult to say, but because I don't really. I have got this question already before, and then some people have been doing some benchmarking. I'm not too sure. There are some other examples where I know the implementation I've made, that it is faster what I've done, but then I think there are also others that it might not be. So I cannot really. I think there's a big difference between the different implementations. What it makes. What I've tried to do, and so therefore it's difficult to say one answer. There is probably different situations and different constraints in which one library is faster than the other. What I have done is to parallelize. If you have a multi-core computer, I have parallelized the extraction for each of the different polygons that are being extracted. I am sending them to a different core if they're available. So if you have a 10-core or an 8-core processor, and you can all use them, and you have many different polygons, it might go 8 times faster as another implementation. If you have a single processor, and or for example, you have a single huge vector where it cannot be parallelized because there's only one vector, but there's millions and millions of pixels below that single vector that you want to take into account for creating the mean, for calculating the mean, then there won't be any performance gain in parallelization. So I think it very much depends on the image and on the number of vectors you have. I would suggest to just test and see. I have some users which were very satisfied by the speed, but I cannot say that it's faster than any other, or so there might be already by now. That's one of the things. But also, I mean, maybe a frustration, but also a very nice thing that by the time you end your program, there are already 20 others that have done a similar thing, which is of course very good for the users because you have plenty to choose from. But I would say just try and see how it performs in your particular case. There's I think we will have some more example on Friday, because they were also in PK Tools. This is different, so it should be actually faster than in PK Tools, but because the parallelization was not done already, so this is something I introduced only for PyGeo and not for PK Tools. So it should be faster if you have a multiple processors, and it should also be faster in the sense that now the entire image is in memory, and it had to be read more piece by piece in PK Tools. So I think I'm interested to see if you have some other examples of other libraries. I would be curious to see how it performs actually myself.
Yeah, we can test this. So it's like spatial statistics and yes, those kind of libraries that
yeah. Or if you have some I'm also happy to help if you have an example of an image and some polygons, and you you have already some result, or you're stuck with the implementation, just I can help you and write a snippet that you can just copy paste, and then see how it performs on your computer.
Yeah. Okay. Thank you.
Yep. Welcome. Yeah, Giuseppe, maybe just to come back quickly to what you were saying on this spatial library you had for modeling. I have in the tutorial on, let me maybe unmute me when I have shared my screen. I'm going to share a tutorial. Okay, so here you see the screen. Giuseppe, are you with us?
I can see it for whatever it's worth.
Okay,
Yes.
Okay, good. So in this documentation of PyGeo, I have here implemented a random forest ensemble classifier. Again, mostly what you have to do is first to extract, using the same extract function, some ground reference data, also on the pixel values to learn the model. When the model is learned, I'm calling this train test of the scikit-learn package. Here you have the scikit-learn ensemble and the model selection, the metrics, all of sklearn, and this is exactly what I'm doing here. I'm creating the model. I'm running the model, and as we were seeing before, I'm using then the random forest module predict is a function from scikit-learn that returns normally an array of NumPy, a NumPy array, and I'm just using this representation of NumPy of the PyGeo gym to fill in all the pixels that I get as a return from this prediction here. So this can be done for a random forest classifier, but this can also be done for other types of models. So you find this example here in the tutorial on classification. So there's a random forest ensemble classifier. There's a support vector machine as an example. There's a few examples here that you can use as a reference if you want to test some things maybe with other models. But well, happy to discuss this also with you when we're live in Matera, Giuseppe. Then maybe we can see further how we can do things. Fernandez.
Hi. Yes. Can you hear me? Am I
Yes.
audible? Awesome. I was curious about the memory limitations as compared to using the command line interface versus PyGeo.
You mean when you talk about the command line interface, are you talking about pktools, or are you talking about
Using
okay.
pktools, yeah.
Okay, so that's a very good point. Very interesting. When I was, as Giuseppe was saying, the pktools originates from more than maybe 20 years ago. So when I was implementing those was mostly for my PhD, then memory constraints were much more of an issue than today. And so if with respect to the memory footprint, pktools is much more memory efficient, because I'm dealing there with a line per line. If I have to process an image, I'm reading a line, processing the line, writing the line, reading the line. So it's very compact in memory. However, with technology changing and memory becoming much cheaper and abundant, I saw that this was really holding back the performance, because all this I/O operations was very heavy and not needed for most of the operations. That was one thing, and so I changed. That was one reason to change because it was memory was available. A second reason was that when I was then doing this change from PK-tools to PyGeo, there was just in the time when I was starting to work with Sentinel images, which were formatted or stored in JPEG 2000 format, and JPEG 2000 is very difficult format to go in a line by line because it is compressed in blocks, and to decode one line of an image, if you have a line of let's say 2000 samples, to read the first line you have to decode an entire block of image just to have the first pixel. So if I then go to the next line, you have to do another block, and then so this was very inefficient, and so that was not working well with PK-tools. And so this was also another reason why going to reading the entire image into memory was gaining a lot of performance. So that's one part of the answer. Just the second part is that you could question now, are we being stuck now? What suppose I'm dealing with a very big image and I'm not able to read it into memory, all of it into memory. There is a way that I implemented in PyGeo that is dealing with tiles. So you can say, read me the image, but I want to be it in tiled in like 64 different tiles, 8 by 8, and I want to deal now with the first tile and then with the second tile. So this is for that I implemented for memory reasons, if you want to deal with big images, but mostly also because where I'm working in the GRC, we have also a cluster of a big cluster of like more than 1,000 cores, and if I'm processing images, I can tile the image and then send each tile to a different core, and then all these core can be processed in parallel and then back created into one big image later on. So this is also a very performant way of dealing with big images. So you can then have the benefits of having it in memory for the speed, but also you can tile it if needed for the memory footprint.
Right. So if I understand right, like Dask does it for parallelization, you do something similar, but for memory limitation.
Sorry, say that again, please.
Dask does something similar, right?
Yes.
For parallel, to run it parallel, while you do it for memory limitation.
Yeah, but I also do it for, as I say, for the cluster. I also do it for parallelization. But I must say, what I implement is a very simple way of doing it, because there's still some what the Dask is doing it in a much more intelligent way, because everything is done behind the scenes. It automatically distributes over the available cores, where I still have to deal with the orchestration of the there's more manual work in my case, where Dask is doing it all automatically. So I don't say it is it's not comparable. What Dask is doing is it's at a much very high level than what I'm doing.
Okay, all right. Thank you.
Welcome.
Thanks, Peter. I'm without video. If not, my connection go down.
Okay.
Yeah, thank you very much. I want to highlight that we will presenting also these tools in the for the prediction and also for the extraction in the next week, when we're starting all the modeling framework. So there will be the typical data extraction, the machine learning implementation, and then back to the prediction on the raster. So we will have occasion to share with all the students and also with you. I don't know if anyone else has other question, and sorry again for the installation procedure. We will try to come across with a solution, or maybe presenting a Docker for the next Friday. So be aware that tomorrow we'll probably receive some email from us concerning what to do to have in my machine. Anyway, if you want to keep trying testing, because that one, what Pieter Kempeneers has been presenting also the way of removing the Python folder and using pip3 uninstall and so on is the way to go. I did in the same way, but after several trials I succeed. So you can also that one is a sorting of learning procedure for dealing with installation in general. So feel free to do it, because you are not going to breaking more than what as it is now. So yeah. So
I think also, Giuseppe, it's very important that you try to do all the steps manually instead of like what I fear is that it somehow got stuck by maybe memory constraints or of the virtual machine that was not fast enough. I would suggest to copy line by line the content of the installation script, and then doing it line by line manually in a command line, and then see where things got stuck. And probably what I expect is what we were seeing also with initially, that it was working, and I would expect that it will also work with the others if you do it just step by step.
Okay, thanks for the suggestion. Okay, so is there any other question?
Just a quick overview over how the fix worked. So we edited the bash file, like you wrote it in Mattermost. We had to remove not one line, but one section of one line.
Perfect.
So
first of all, remove the use of multi-core implementation. So just leave the make, like I wrote in the Mattermost. Okay.
So,
and
so the line after the change is just make.
Yeah. When they say, did it? I wrote, where it was perfect. So you have to remove the -J $ and CPU. So remove that one from everywhere. Also because in this way you are going to use only one CPU. And of course, when you use one CPU, the RAM will be much less because only one CPU is occupied the RAM. First of all, and then you can also, like Pieter was mentioned, in order to do step by step, you can even comment all the section and leave it alone only one section, not to comment one section, and you run the script. And then when is over that section, you change the commenting, and you go uncomment the other one, and you keep progress. In this way, you can also see where it stopped,
Yeah, or even just copy the lines from your script and paste them in a command line and doing it one line by line.
Yeah, that one is also better because you learn how to do it and when the error is doing and so on.
Yeah.
Okay.
And then for me, it actually did run through, but I'll just try it again because I had this error that X-array says it's the wrong version, even though when you check it is the correct one.
Yeah, perfect. So try to use pip3 show X-array will give you what pip is using, and then search with the find where is the X-array folder, and then remove manually with the command line that folder.
Yeah.
Eventually use sudo if you if you get permission denied. Okay.
Yeah.
And then you can, after reinstalling, you can redo pip show to see if you get the 21 version.
Okay, thank you.
Yeah.
Maybe one last thing is that if by doing these things, you should not be in a virtual environment. So installing and uninstalling, you should be just on a regular terminal and deactivate in case you are in a conda or in a virtual Python environment. I think these things can also be mess up a bit the things that you don't know anymore what is installed and if you in which environment you are. So I would suggest to go out to deactivate in case you have activated any environments to deactivate them and just to be in the plain vanilla environment of your Linux.
Mm-hmm.
Okay, perfect. Thanks, Peter. Anyone else? Some other question? Okay, so we can resume the lecture.